Now we are going to start the next chapter, chapter 6 of class 9th mathematics, and this is the first lecture. So the name of the chapter is lines and angles. So in this first lecture we will basically discuss about the basic definitions related to angles and some new terms you will also learn over here. So the first definition we have, it is angle. So we are saying if two rays they originate from the same point, a point A is given to us, and we are saying two rays they are originating from the same point A, then the angle is formed in between those two rays. This thing we are saying, this is the measure of this is called the angle, and these two rays, these are called the arms of the angle, and A is called the vertex. So the same thing is represented over here. We are saying AB is a ray and AC is a ray, and the angle, this angle is denoted by angle BAC. This is the symbol for the term angle we are saying, or it is representing the angle CAB, or you can write it is angle A. So how we are writing this? This A is over here and we are writing this A in the middle over here. This A we are writing in the middle over here. It means this B, then A, then C. So A is the angle over here. So arms, in this case it is AB and AC are the arms, and this A is the vertex. And if we measure an angle in terms of degree, the units over here we have, it is degree and it is denoted like this. So if we are writing it is 60 degrees. We will see what degree is in our next slides. And measure of the angle, we can write it like measure of angle A is equal to 60 degree, but generally in general we do not write every time M over here, and we write angle A is equal to 60 degree. So both of these, the meaning of both of these, it is same. Next there are some terms. It is acute angle, right angle, obtuse angle. So acute angle is if the angle lies, the value of the angle, the measure of the angle, it is more than 0 and less than 90. We are saying it is the measure of the angle. If suppose I am talking about some angle, say x degree, so we are saying 0 degree is less than x degree is less than 90 degree, then it is called an acute angle. If the measure of the angle is equal to 90 degree, it is not equal to over here, equal to sign is in this definition. If the measure of the angle is equal to 90 degree, we are saying it is an right angle. And if the measure of the angle is between 90 degree and 180 degree, then it is called an obtuse angle. So these are represented over here. We are saying this is acute angle, right angle, and obtuse angle. So if we are saying the angle, say 79 degrees is given to us, so it is an acute angle. If it is 91 degrees is given to us, it is obtuse angle, and if it is exactly 90 degree, then it is called the right angle. Next we have, so what we have done, we have started from 0 to x to 90 degrees, then we are saying it is equal to 90 degrees, then we are saying 90 is less than x is less than 180 degree, and if it is equal to 180 degree, then it is called the straight angle. And if the angle is more than 180 degree and is less than 360 degree, then we will say it is a reflex angle. So reflex angle means, if suppose I am talking about this, so this angle I am talking about, this will be the reflex angle. In this case this will be the reflex angle. In this case this angle will be the reflex angle, because the measure of all these angles, this will be greater than 180 degrees. Next is, if the measure of an angle is 360 degree, that is equal to 360 degree, then it is called a complete angle. So this is, in this figure, this is the straight angle, and then in the next figure it is the reflex angle, and this is the complete angle over here. So if the measure of the next definition we have, it is if the measure of the two angles is same, the angles are said to be equal. So we can write it like angle A is equal to angle B. This is same as writing like measure of angle A is equal to measure of angle B. So both these, you can use any of these notations, but in general we do not write M every time, we just write angle A is equal to angle B. So its meaning should be clear to you, that we are saying that measure of both these angles, these are same. Now the next definition we have, it is angle bisector. So we are saying, suppose the angle over here, this AB is a ray, AC is a ray, and we are saying it is forming the angle over here. This angle, it is this angle we are talking about, it is angle BAC, or we are saying it is angle CAB. Then we have drawn another ray, that is AD. We have drawn another ray, it is AD, and how it is drawn, we are saying that angle BAD, that is equal to angle CAD. That is, we are dividing these two angles. Suppose this is angle 1, this is angle 2. If angle 1 is equal to angle 2, then we say that this AD, this ray AD is the angle bisector of angle BAC. Now the next definition is interior of an angle. Again, suppose an angle is given to us, this is AC, this is AB, then interior of the angle means this portion we are talking about. This is the angle we are talking about, this is the angle A, this is the reflex angle, this is the reflex angle A. These are the names. This is angle A and this is the reflex angle A. So interior of an angle means we are talking about the plane or the region which lies on the same side of AB. This lies on the same side of AB as is the C. So C is on this side of AB. So this is the region over here, and similarly it lies on the same side of AC as B. This point B is there. This line is, suppose I am saying this is a line, then this AC is there. We are saying it lies above AC and it lies on the right side of AB. This region is called the interior of an angle. Next is the definition of exterior of an angle. So exterior of an angle is, we are saying all the points which are neither lying on the angle, on the rays, or nor they are lying in the interior of an angle. Those are called the exterior angles. So this figure is given to us and we have to tell which of the points which are interior and which are exterior to the angle A. So it is clear over here that this point F, D, E and G, these are interior, and the points, these points we are talking about K, J and L, these are the exterior. These points, these are the interior and these are the exterior. Next is the definition of complementary angles. So we are saying if the sum of measure of two angles is 90 degree, then they are called the complementary angles. So angle measuring, here this example is given over here, 65 and 25. If you add both these values, it is 65 plus 25, the answer is 90 degree. So what we say, that the angle measuring 65 degree and 25 degree, they are complementary angle. Similarly, if the sum of the angles is 180 degree, in this case the sum of the angle is 90 degree, in this case the sum of the angle is 180 degree, then the angles are called supplementary angles. So two supplementary angles are also called supplement of each. Similarly, as we are talking in this case, we are saying when the angles are complementary, when x, angle measure of x and measure of y, sum of x and y, it is 90 degree, and they are supplementary if x plus y, it is 180 degrees. So if we look at an example, so 62 degree plus 118 degree angles, if we are taking their sum is 180 degree, it means both these angles, these are supplement of each other. Next is find the measure of an angle which is 24 more than its complements. This is the questions we have. Find the measure of an angle which is 24 degree more than its complement. So let us consider the angle we are finding. That angle is x, the measure of that angle is x degree. So measure of its complementary angle is 90 degree minus x degree, or you can write 90 minus x degree. That will be the measure of its complementary angle. The measure of complementary angle means their sum should be 90. So what we get is that x minus 90 minus x, that is equal to 24, because it is given that it is 24 degree more than its complement. So when you solve this equation, you will get it is x minus 90 plus x is equal to 24. So it is 2x minus 90 is equal to 24. This implies 2x is equal to 114, and this gives us x is equal to 57 degrees. So what we have done, we are saying if the angle is x, that the angle will be x, then its complementary angle is 90 minus x. Now in the next question we have find the measure of an angle which is 32 degree less than its supplement. So this is similar question, is this also the similar question, but the difference is in this question we are talking about complement, in this question we are talking about supplement. So what we are saying is, suppose the angle we are measuring, it is of measure x degree, then the second angle will be 180 minus x degrees, because we are talking about its supplementary angle. What we mean to say is suppose this is a straight line given to us, we are saying this angle is x degrees, we want to find its supplementary angle. Supplementary angle means the sum of the two angles should be 180. So it means we are trying to find this angle y degree, and we have x degree plus y degree is equal to 180 degree. So we get y degree is equal to 180 minus x degrees. This is what we are saying over here, that if the measure of the angle is x degree, then its supplementary angle will be 180 minus x degrees. Now it is given that the measure of the angle is 32 less than its supplement. So which of the angles is greater? Supplement angle is greater, because this is 32 less than the supplement. So we are saying 180 minus x, this is the greater angle, minus x, this is the smaller angle, and the difference between these two is 32. This is how we are getting this equation. On solving this, you will get 180 minus 2x is equal to 32, and you will solve this value, you will get x is equal to 74. So this is the answer. Now in the next question, we have two supplementary angles are in the ratio 2:3. So if two angles are in the ratio 2:3, we suppose that their measures are 3x degrees and 2x degrees. Now it is given that these are supplementary angles, so it means 3x plus 2x, their sum is 180 degree. Why? Because it is given that they are the supplementary angle. Because they are in the ratio 3:2, we are writing it is 3x degrees and 2x degrees. So when you will solve this, you will get the value of x is 36. So the two angles are 3 into 36 and 2 into 36, that is 108 degree, and this is 72 degrees. Now the next question is, the supplement of an angle is 1/3 of the given angle. So what we require over here, suppose the given angle is x, so the supplement of that angle will be 180 minus x degrees. This thing we know now, that if the given angle is x, its supplement will be 180 minus x degrees. And what we have to do is, we have to find the measure of the given angle and its supplement. So it is given that it is 1/3 over here. So what we get from this is, what this equation says is that 180 minus x is 1/3 of the given angle. So when you solve this, you will get, we are multiplying both sides with 3, so you will get 3 into 180 minus x is equal to x. So you will get it is 540 minus 3x is equal to x. So 4x is equal to 540. So x is equal to 135. So the two angles we are talking about, one is 135 and second is 180 minus 135 is 45 degrees. Now in this next question, it is given that we have to find an angle if 7 times its complement is 10 less than the 3 times its supplement. So suppose the given angle is x degree. So complement of that angle will be 90 minus x degrees and supplement of that angle is 180 minus x degrees. Now what is given is 7 times the complement of that angle is 10 less than 3 times the supplement of that angle. It means, what this means is that this is supplement of the angle. We are saying 3 times the supplement of angle. This is greater value because this is 10 less than this. So we subtract 10 from the supplement of angle and it should be equal to 7 times the complement of that angle. I am again explaining how we are writing these terms. From the question, it is given that 7 times its complement is 10 less than, when it is given 10 less than its supplement. So first thing we are talking about is which one of these is greater, complement of that angle is greater or supplement of that angle is greater. It is supplement of that angle is greater. So we are saying whatever the value of supplement angle, when we subtract 10 from it, the answer we are getting it is the complementary angle, because complementary angle is 10 less than the supplementary angle. So how we are going to solve this? You multiply these terms, you will get it is 630 minus 7x, that is equal to 540 minus 3x minus 10, and on solving this you will get 4x is equal to 100. So the value of angle that is equal to 25 and x is the required angle. Next we have is the definition of adjacent angles. So what definition says is, we are having two angles and they have the same vertex. It means I am talking about some vertex is given to us and we are having the two angles. First property is they have the same vertex. Second is they have a common arm. Suppose this is the common arm I am talking about. Common arm means now the two angles are like this. This is one angle with this arm and this is the second angle with this arm. And their non-common arms are on the either side of the common arm. So what we would have drawn over here, it would have been like this, that this is the common arm, and we would have drawn it like this, that this is the one angle and this is the one angle and this is the second angle. But we are not talking about this case because this is contradicting our third condition. This is wrong because this is contradicting our third condition. So our three conditions are, first is that they have the same vertex. They have the same vertex. Second is they have a common arm, and third is that they lie on the both side of this common arm. Then those angles they are called the adjacent angles. So same thing is explained in this figure, that OC is the common arm, O is the vertex, common vertex, and OA and OB they lie on either side of OC. Next definition we have, it is the linear pair of angles. So last definition we have seen the definition of the adjacent angle. So we are saying two adjacent angles are said to form a linear pair if their non-common arms are opposite rays. In the last definition we are saying this is the common arm and we have drawn the non-common arms over here. Now in this definition what is there, that the non-common arms, this is suppose the common arm, we have drawn a non-common arm, this is the common arm, this is the first non-common arm we have drawn, and the second non-common arm is the opposite ray. It means if this is the ray OA, opposite ray means its vertex is O but it is in the opposite direction. So how we are going to draw that arm is, it is like this, this is B. It means what we are talking about is that this total angle over here, this total angle is 180 degree. This is the common arm. Then these two angles we are talking over here, that this angle and this angle, these two angles, these form the linear pair. So linear pair basically means that the sum of the angle is 180 degree and they have a common vertex. Now the next thing we are going to do is, we have seen over in the previous definition the definition of linear pair. So in the next question we are going to prove that the sum of angles of a linear pair is 180 degree, that is those angles, they are the supplementary angles. So same thing is stated over here, if a ray stands on a line then the sum of adjacent angles so formed is 180 degrees. So what is given to us is a ray CD stands on a line AB such that angle ACD and angle BCD are formed. So what we mean to say, that a line AB is given to us, this is AB, a line AB is given to us and a ray CD, it stands on the line AB. This is our ray C, this is D, such that it forms two angles, one is ACD, one angle it is forming, it is ACD, and second angle it is forming, it is BCD. These are the two angles it is making. What we have to prove is that the sum of both these angles, sum of these two angles is 180 degrees. So how we are going to prove this is, we are going to do some construction over here. Construction means to prove something we are going to draw over here. So we draw a perpendicular at this point C and we name this is, say we have drawn a perpendicular CE, is mentioned over here, we have drawn a perpendicular CE on AB. So now what we have is angle ACD is equal to angle ACE plus angle ECD. So what this in the figure we are talking about, ACD is this whole angle and we are saying it is ACE plus angle ECD, and similarly we are saying angle BCD, we are talking about now, this is B, this is C and this is E and this angle is D over here, this point D is over here. So we are saying that angle, this angle BCD, that is equal to this larger angle, this angle minus the angle DCE. So we have two equations over here. One is angle ACD, that is equal to angle ACE plus angle ECD, and second is angle BCD is equal to angle BCE minus angle ECD. Now if we add these two equations, we say it is the sum of these two angles, angle ACD plus angle BCD. When you add these two angles, these are same, this gets cancelled out, and what we are left over here, it is angle ACE plus angle BCE. Now these two angles, these are of 90 degrees. This angle is, both these angles, these are 90 degrees over here, because we have drawn the perpendicular over here. So their sum is 180 degree, and hence we get angle ACD plus angle BCD is 180 degrees. So this is the same as saying the sum of the angles of a linear pair is 180 degrees. Now the next question we have, prove that the sum of all angles formed on the same side of a line at a given point on the line is 180 degree. So suppose a line AOB is given to us. We are saying AOB is a straight line that is given to us, and rays OC, OD, OE stands on it. So what we have to prove is, we have to prove that the sum of these angles is 180 degrees. So from the figure we see that this AOB is the line. We have drawn the rays on this. The rays we have drawn OC, OD and OE, and we are saying that sum of all these angles, that is AOC, this angle is AOC. Next we are talking about is angle COD. Next we are talking about the angle DOE, and last we are talking about the angle EOB. The sum of all these angles is 180 degrees. So from the previous result, what we have is the ray OC. We start with this ray. We are saying, we are just considering it like this, that this is AOB and this ray C is there. And from the previous result, we know that whenever the ray stands on a line, then the sum of the angles is 180 degree. It means angle AOC plus angle OCB is 180 degree. And it is clear from the figure that if I am talking about angle COB, I can write this is equal to angle COD plus angle DOE plus angle EOD. Thing is mentioned over here. So these values are equal. We substitute these values over here, and what we get is that angle AOC plus angle COD plus angle DOE plus angle, this is, we are saying this value we have substituted in place of COB, because angle COB is equal to this. So we are using, in this case we are using this value, that angle COB is this. So when you substitute this value, you will get the sum of all these angles is 180 degrees. The next result we have to prove is, prove that the sum of all angles around a point is 360 degree. So what is given to us, a point O and rays OB, OC, OD makes angle around O. We are saying this point O is given to us, and we are having different rays over here. It is OA, OB, OC and OD, which makes angles around this point O. And what we have to prove is that sum of all these angles, we have to prove is angle AOB plus this sum of all these angles, it is 360 degree. We are talking about these angles over here. We have to prove that sum of these angles is 360 degree. So what we are going to construct is, this is the construction part over here. We are saying what we are going to construct is, we produce the ray OB backwards to a point E such that EOB is a line. You can, it is not necessary that you extend this OB, you can extend any one of these rays. You can extend any one of these rays. It is not necessary that we will extend OB. You can extend A also. If suppose I am extending A, I will get it like this E will be over here. So now what will happen over here is, if I am looking at this ray, suppose I have extended it over here, so what I am having now is, this is like E and this is B. Now I am having this A is over here, then we have this D is over here and C is over here. So I am writing different angles like this. This is suppose angle 1, this is suppose angle 2, next we have is angle 3, next we have is angle 4, and this is angle 5. Now this is the point O we have. Now we are saying OA, it lies on the line EB. EB is a straight line and OA lies on this line. It means angle 2 plus angle 1, that is equal to 180 degree. The sum of these two angles will be 180 degree because they lie on a line. Similarly, when we are talking about what is angle 3 plus angle 4 plus angle 5, that is also equal to 180 degree, because these three angles, when we are talking about angle 3, 4 and 5, they also lie on the same line EB. We are saying these three angles, these also lie on the same line EB. So we are having two equations now. This is equation number 1 and this is equation number 2. If we add these two equations, we will get angle 1 plus angle 2 plus angle 3 plus angle 4 plus angle 5, that is equal to 360 degree. 180 plus 180 is 360 degree. Now angle 2 plus angle 3, it is angle AOD. Angle 1 is angle AOB, angle 4 is angle DOC, and angle 5 is angle COB, and the sum of all these angles is 360 degree, and this is what we have to prove. Now the next result we have is, if we have to prove is, if the sum of two adjacent angles is 180 degrees, then the non-common arms of the angles are a straight line. So how we are going to prove this is, we are going to prove this by contradiction method. So we suppose that the non-common arms, they are not the straight lines. So what we are talking over here, we are saying, suppose we are considering two adjacent angles. This is A, this is B, and this is C. We are talking about these two adjacent angles, and we are saying the sum of these two adjacent angles is 180 degrees. But the non-common arms means we are talking about this arm and this arm. We are saying suppose they are not in a straight line. So if they are not in a straight line, what we are going to do, we are going to make them in a straight line. So we are going to do some construction, and we say we extend this OA to some point D such that AOD is a straight line. Why? Because we are saying, we have supposed that this is not a this AOB is not a straight line. So we are saying we can construct OD such that AOD is a straight line. Now if AOD is a straight line, then we are saying AOD is a straight line and OC, it lies on this straight line. Then we have the sum of these two angles, that is angle AOC plus angle COD. The sum of these two angles is 180 degree. Why? Because it is a linear pair. The second thing that is given to us is that angle AOC plus angle BOC is 180 degrees. So if we subtract these two equations are there. If we subtract these two equations, AOC and AOC gets cancelled, and we are left with angle COD minus angle BOC is equal to 0. So it means angle COD is equal to angle BOC. So what we have reached from what this thing tells us, this is not true since a part cannot be equal to the whole. We are saying this is the part of this angle and this cannot be equal to the whole, so our supposition is wrong. So this thing is important over here, that what we are using over here, that because we have considered this thing, what we have assumed over here is, we have made the assumption, this assumption we have made that the assumption we have made over here, it is that this is not a straight line. So because of this assumption we have reached a contradiction. So we are saying our assumption is wrong. So if our assumption is wrong means we are saying that AOB is a straight line. Next is the definition of vertically opposite angles. So we are saying two angles are called a pair of vertically opposite angles if their arms form two pair of opposite rays. So in this figure, if we are talking about, we are saying this angle AOC and this angle DOB, these two angles, these are vertically opposite angles, and these two angles, these are vertically opposite, these two angles, these are vertically opposite angles. So why? We are saying their arms form two pair of opposite rays. Suppose I am talking about this is an angle, then this arm will form the opposite ray, this arm will form the opposite ray. So the angle that I will get over here, it is this. So we are saying these two angles, these are vertically opposite angles. Now the next theorem we have to prove is, if two lines intersect, then vertically opposite angles are equal. This is the theorem we have to prove, that if two lines intersect, then the vertically opposite angles are equal. So what is given to us is two lines A, B and CD intersect at point O. We are saying this is one line AB and this is another line CD. They intersect at O. What we want to prove is that angle AOC is equal to angle BOD, and the angle AOD, this angle we are talking about, this is equal to the angle COB. That these two angles are, these pairs of angles, these are equal. So how we are going to prove this is, suppose I am talking about this straight line CD, then what we have is that this AO, it stands on this line, so the sum of these two angles is 180 degree. This is mentioned over here that angle AOC plus angle AOD is 180 degree. Why? It is the linear pair property. Now the second thing we are saying is, if we are talking about this line over here, this is B over here, this is also a straight line, and OD, this OD, it stands on this straight line AOB. So what we get is that the sum of the angles AOD and BOD is also 180 degree because of the linear pair property, or the definition of the linear pair. So from this what we get, both these values, these are equal to 180 degree. So equals are equals Equal, the equal means we are talking about the axiom that this is equal to 180 degree, this is equal to 180 degree. It means both these are equal. So we get that angle AOC plus AOD, this is from this term, is equal to angle AOD plus angle BOD. Now AOD gets cancelled in both the cases, and what we are left with is that angle AOC is equal to angle BOD. Similarly, we have the two arms we are considering over here. First, we are saying this is the straight line, and we have considered this as the line or the ray standing on this line, and we have considered this as the ray standing on this line. Similarly, if we consider that OC stands on AB and OB stands on CD, we can prove the second part, that is angle AOD, that is equal to this thing we have proved. We can prove that angle AOC is equal to angle BOD. Now in the next question, it is given that AOB is a straight line. AOB is a straight line, and we have to find the angles. This x, this is given 65, this is 2x minus 120. So if this is a straight line, it means sum of these angles, x plus 65 plus 2x minus 20, sum of all these angles, this will be equal to 180 degree, because the sum of the angles that lie on a line, their sum is 180. We have seen this in the theorem. So when you will solve this, you will get the answer like this, that it is 3x is equal to 135. So the value of x you will get, it is 45 degrees. So the angles we have, it is this angle you will get, it is 45 degree, and this angle, when you will substitute the value over here, you will get the value of this angle is 70 degrees. Similarly, in the next question, it is in the adjoining figure, what value of x will make AOB a straight line? So AOB will be a straight line if sum of these two, 3x plus 5 into 2x minus 25, sum of these two is 180 degrees. So this is the equation we have to solve. So when you solve these values, this is 5x, and when you calculate these values, you are left with 200. So the value of x you will get, it is 40. Now in the next question, we have to calculate the angles AOC, angle AOC, angle BOD, that is we have to calculate the value of x, y, and we have to calculate the angle AOE, and it is being given that angle COD, this angle is 90 degree, this is 72 degree, and AOB is a straight line. So if AOB is a straight line, so what we get is 3x plus 72, that will be equal to 180 degrees. So it means 3x is equal to 108. So the value of x you will get, it is 36 degrees. So this value is 3x. So value of 3x is 108 degrees. So this angle you will get, it is 108 degrees. This angle you will get, it is 36 degrees. Again, AOB is a straight line. This AOB is a straight line. So what we get is that the sum of these three angles, 36, 90 and y, it should be equal to 180 degree. So we are saying 36 plus 90 plus y. These three angles we are talking over here, and these two angles we are talking over here. So sum of these three angles is 180 degree. So when you will solve these values, you will get, it is 126 plus y is equal to 180 degree. So the value of y you will get, it is 54 degrees. So these are the three values that we have to calculate. Now in the next question, it is given that ray OC we are talking about, this is ray OC, this stands on a straight line AOB. This is a straight line given to us, and ray OD and OE are the bisectors of angle AOC. So we are saying this is bisector of this angle, means that this angle is equal to this angle, and second thing that is given to us is this angle is equal to this angle. Now we have to calculate the measure of angle DOE. So suppose we are saying that the value of this angle is x, you will get this angle is also x. Second thing we are having over here, if this angle is y, then this angle is also y. Now what we get from this is that the sum of all these angles, that is x plus y, sum of all these angles x, y and y, that is equal to 180 degree. So you get it is 2 times x plus y is 180 degrees. So the value of x plus y you will get it is equal to 90 degrees. And what we have to calculate is we have to calculate the angle DOE. So angle DOE means we are talking about we have to calculate the value of x plus y, and it is equal to 90 degrees. Now in the next question, it is given that XY and LM, they are two lines, they intersect at O. So XY and LM are two lines which intersect at O. Further, the angles are given over here. This XOL is A, LOP is B, and likewise other angles are given. And one more thing is given over here, that the ratio of A is to B is 2:3. So ratio of A is to B is 2:3 means if suppose the you can write it like, if the ratio of A is to B is 2:3, it means if A is 2x, then the value of B will be 3x. So basically it is given that A is equal to 2x and B is equal to 3x. Now XOY is a line. Now XOY is a line means 2x plus 3y plus 90 degree. We are talking about these three angles. This is 2x, this is 3y, and this is 90 degree. They lie on a line, so their sum is 180 degree. And this is x over here, this is not y, this is x over here, this is 3x. So the answer you will get it is 5x is equal to 90 degree. So the value of x you will get it is 18 degrees. So the two angles we have, this angle is 36 degree and this angle is 54 degrees. Now LOM is a straight line. When this is a straight line, it means 2x plus c is equal to 180 degree, because this OX, this lies on the straight line LOM. So we get 36 plus c is equal to 180 degree. So we get the value of c is equal to 144 degrees. So the next question we have is, in the given figure, if x plus y plus equal to z plus w, we have to prove that AOB is a straight line. So these all angles we have over here, this is x, y, z and w, they are around a point. So the result we have is that x plus y plus z plus w, that is equal to 360 degree. This value is equal to 360 degree. Now it is given to us is that x plus y is equal to z plus w. So we put these values over here. We write it is x plus y in place of z plus w. We are writing x plus y. So we get it is plus x plus y, that is equal to 360 degree. So we get 2 times x plus y is 180 degree. So x plus y is this is 360 degree over here. It is not 180, it is 360 degree. So we get x plus y is 180 degrees. So what we are saying over here, that sum of these two angles is 180. Similarly, the sum of these two angles is 180. So if the sum of x and y is 180, that sum is 180, it means this will give us that AOB is a straight line. Now in this question, it is given that angle PQR, this angle, is equal to angle PRQ. Suppose the value of this angle is x and value of this angle is x. Now we have to prove that the PQS, suppose it is, we are saying it is y, and PRT, suppose we are saying this is z. We have to prove that these two angles, these are equal. So what we have now is, we are saying if this is a straight line, so what we get is y plus x, that is equal to 180 degree. And if this is a straight line, then this angle x plus z will be equal to 180 degree. So we have two equations now. One equation is x plus z is equal to 180 degree, and second is x plus y is equal to 180 degree. So when we subtract these two equations, this x gets cancelled, 180 is 0. So we are left with this z minus y is equal to 0, which implies z is equal to y, and this is what we have to prove over here. In this question, it is given that angle XYZ, that is 56 degrees, and XY is produced to a point P. XY is produced to a point P means this is a straight line. If ray YQ bisects this ray YQ we are talking about, this is YQ, this is bisecting the angle ZYP. It means this angle and this angle, these are equal angles. These two angles, these are equal angles. We have to calculate the value of XYQ. So we have to calculate the value of XYQ. This larger angle we have to calculate. We have to calculate the value of this angle, and reflex angle QYP. So what reflex angle means? It is, we are talking about, it is greater than 180 degree. So QYP reflex angle is this. So if suppose we are saying, we name these angles, we are saying this angle is x, then this angle is also x. Now PYX is a straight line. So what we get is x plus 56, that is equal to 180 degree. So we get 2x is equal to 180 degrees. So the value of x you will get 180 minus 56. So 2x is equal to 124. So the value of x you will get, it is 62 degrees. It means this angle is 62 degrees. This angle is 62 degrees. So this larger angle will be 62 plus 56, that is equal to 118 degrees. We are saying this angle is 62 degree, this angle is 56 degree. So sum of both these angles is 118 degrees. And second thing we have to calculate is that this is the line over here, this angle is given to be 62 degree, and we have to calculate the value of this reflex angle. So the whole angle, the value of this whole angle is 360 degree. So the value of this angle will be 360 degree minus 62 degree, that is equal to 298 degrees. Now we are given three concurrent line. Concurrent line means which intersect at a point, those lines which intersect at a point, more than two lines we are talking about, if they intersect at a point, they are called the concurrent lines. So it is given that AB, then this CD and these three are the concurrent lines, and we have to find the value of y. Now first thing we see from this is that if I am talking about these two lines, that is EF and AB, we see that these two angles, these are vertically opposite angles, and we know that the vertically opposite angle, they are equal. It means if this angle is 5y, then the value of this angle is also 5y, because these two angles, these are the vertically opposite angles. Now these three, 2y, 5y and 2y, they lie on a straight line CD. It means 5y plus 2y plus 2y, that is equal to 180 degree. So 9y is equal to 180 degree. So we get the value of y is 20 degrees. So now the next question is, in this figure, AB is a mirror, PQ is the incident ray. This AB is the mirror. We are saying PQ is the incident ray and QR is the reflected ray, and the angle PQR is given to be 112. Now it is a property of the mirror that when a ray falls on a mirror, it is reflected and the angle of incidence is equal to angle of reflection. So angle of incidence and angle of reflection means we are talking about these two angles. That angle of incidence is this angle and angle of reflection is the angle this, that is MQR is the angle of reflection, and PQM, this is angle of incidence. And it is property of the mirror that both these angles, these are equal, and we are saying, supposing that these angles are equal to x. Now what the figure, if we draw the figure again, what we have is this angle is 90 degree, this is M over here, then P is incident ray and Q is the reflected ray. We are saying this angle is 90 degree. What is given to us is that this whole angle is 112 degree. What we have considered over here, suppose this angle is x and this angle is x. Now what we have is that x plus x is 112 degree. So the value of x you will get, that will be equal to 112 by 2, that is equal to 56 degrees. The value of x you will get, it is 56 degrees. Now when we are talking about the angle AQM, that is equal to 90 degree. This angle we are talking over here, this angle is 90 degree. So the angle we are left over here, we are talking about this angle. This is 90 minus 56 is equal to 34 degrees. So this angle will be of 34 degrees, and this is what we have to find. It is angle PQA we have to find, and its value is 34 degrees. Now the next thing we have to prove is the bisector of a pair of vertically opposite angles are the same straight lines. So suppose we are talking about two vertically opposite angles, one is this line, second is this line. So we are saying, suppose these are the vertically opposite angles we are talking about. So the bisector of this angle is over here and the bisector of this second angle is over here, and we have to prove that this is the point of intersection O, we have to prove that this line we have drawn over here, this is one line and this is the second bisector. So we have to prove that this is the straight line. So what we are going to do now is, we are saying, suppose what we have considered over here, that the sum of all these angles, angle AOC means we are talking about this complete angle. This angle is angle AOC. Angle BOC is this next angle. Then we are saying plus angle BOD is this next angle, and last we are talking about is angle this. So sum of all these angles, sum of all these angles, it is 360 degrees. And these two angles, when we are talking about these two angles, these are vertically opposite, so they are equal. So we are talking about the angle COB, that is equal to angle AOD, because these are vertically opposite angles, so they are equal. So we are writing this is 2 times BOC. Why? Because angle BOC is equal to angle BAOD. Now next thing we have is, when we are considering the angle AOC, we are saying it is 2 times angle EOC, because this is the line, this is the angle bisector. Angle bisector means that the sum of these two, we are talking about, it is the angle bisector over here. So it means that this angle, we are talking angle EOC and angle AOE, they are equal. So we are writing it is 2 times EOC. Similarly, when we are considering angle BOD, we are writing it is 2 times angle BOF. So from this equation we can take 2 common. So we are left with this 2 times angle EOC plus angle BOC plus angle BOF, that is equal to 360 degree. When you divide this equation with 2, you will get it is 180 degree. So what is this angle EOC? EOC we are talking about, this is EOC. Next we are talking about is BOC. BOC means this is first angle we are talking about. BOC is this angle, and the next angle we have it is BOF. So it means the sum of all these 3 angles over here, these are the 3 angles we are talking about, their sum is 180 degree. And if the sum of these 3 angles is 180 degree, then it implies us that EOF is a straight line, and this is what we have to prove. Now in this question it is given that the ray OC is a ray, it is bisector of the angle AOB. Suppose we are saying this value is X and this value is X, and OD is the ray opposite to OC. This OD is the ray opposite to OC. So what this thing means is that this total angle is 180 degree, because this is the straight line. So this total angle will be 180 degree. Now what we have to prove is, we have to prove that AOD, that is equal to BOD. So if we are talking about the angle AOD, the value of angle AOD will be 180 degree minus X. Similarly, the value of the angle BOD, when we are talking about this angle BOD, its value will be 180 minus X. And this is what we have to prove, that both these angles, they have the same value. So same thing we have shown over here. Suppose we are saying this angle is Y, this angle is Z. So we are saying x plus y is equal to 180 degree. From this we are saying x plus z is equal to 180 degree. We subtract these two equations, we get y minus z is equal to 0. So we get y is equal to z, and this is what we have to prove.